Hi everybody, welcome to another video in Pre-Calculus section 8.1 Polar Coordinates. Polar coordinates. In polar coordinates, we will have a point, called the point, and then array with a vertex at the point called the polar axis. A point P in the polar coordinate system is represented by a number, by all the pair of numbers r and theta. So if r is positive, r is the distance of the point from the pole, and theta is an angle formed by the polar axis and the ray to the point. So all of that, so we choose a point to be a pole, and then we'll have a ray called the polar axis. And the other point, any point on the plane, will be characterized by two numbers first, or if it's positive, it will be the distance from the pole to the point, and then theta is an angle formed by the polar axis and the ray through the point. So pretty much originally this point in the rectangular coordinate or Cartesian coordinate has x and y. Now instead of using x and y as coordinates, we can use r and theta. And that set of point is called the polar coordinates of the point P. Let's look at some example here. Plot the points with the following polar coordinates, 2 and 4 pi over 3. So if it is 2, meaning that the distance is going to be 2, so it will be in this circle, and 4 pi over 3, so the angle is 4 pi over 3. So 4 pi over 3 is a pi and a third, so it will be that 4 pi over 3. If we go from this polar axis, pi over 3, and r is equal to 2, so from the center 2, so this is the point A. Right. Next, 2 negative pi over 3. Negative pi over 3 is going clockwise. Pi over 3 is the measured angle. So this is negative pi over 3. And r is equal to 2. So this is the point B. Next, 2 and 0, so the distance to the pole is 2, so, and the angle is 0, so this is point C. And finally, this is negative pi over 3 and negative pi. So negative pi over 3 is this ray. However, because of the negative in R, so instead of go along the ray or in the same direction as the ray, we have to go the opposite direction, and this is point D. So if we go the same direction, it's going to be positive, or if we go opposite direction, it's going to be negative. So that is point D. So we're just going to plot. So characterized by two numbers, the distance to the pole and the angle make with the polar axis and the ray go to the point. Right. If R is positive, go in the same direction. If R is negative, opposite direction. And also, the angle here can be any coterminal angle, so we can go extra revolution if we want to. Next, find two more representation of point A in the sample 1, where representation is R is positive, and one representation when R is negative. So we have point A here. So if we want to, it will have 4 pi over 3. So representation for point A, if we keep R to be positive 2, if we add 2 pi to it, we'll get back to the same ray, right? So the angle, we stop, we'll go extra revolution, we will stay at the same ray, which is good. So that is the same as the point A, 2, and 4/3, plus 2, fourth plus 2, and that is 10 over 3. Let's take a pi to it. Right, so that is the coordinate. Different representation, but it will represent the same point. Right, now what if we want to choose A but with the negative? Right, so if it's negative, it cannot be any number like -5 or -6 or any other number. It still have to be -2 because the distance is still in the same direction though. I mean, the distance is still 2. It could be from A to the point or from the point to A. The difference is it could be positive or negative, but the magnitude have to be the same. Right, so what do we do? Now instead of that, this is the ray going out. Now we can also go in the opposite direction. And then instead of go that way, but we choose the opposite direction as R, so it will be negative. So we go in this direction as the angle, but in terms of R, it's going to be -2 to go to this point. So if we want to get to that ray, notice these two rays are opposite to each other, so the angle formed between them is a pi or 180 degrees. So if we want to turn to a negative, what we do is instead of add 2 pi to it, we only need to add 1 pi, or we could subtract a pi if we want to. Here, just add 2 pi to it, and I will have the point A with -2, 7 pi over 3. So the representation is still the point A, but one with positive R, one with negative R. Because if we want positive R, we can go and 2 pi to it. If we want to turn into negative, we have to add half a revolution to go to the other side. Right, so that's what we have in the summary here. A representation of the same point. Different representation in polar, but we have the same representation in the rectangular. Or we could say it's just different representation of the same point. Adding 2 pi to it doesn't change anything because the ray is still the same. But if we add a pi to it, we go to opposite side, so we throw in the negative. So if we want to use different representation of the same point, throw in the negative and then plus a pi. That will go to the opposite direction and then go to opposite again, so we get back to the same point. Right. So that is representation of a point in polar coordinates. Now, how do we change between polar coordinate and rectangular coordinates? Rectangular coordinate, we have x, y. And polar coordinate, we have r and theta. Now if we draw a little sketch, if we choose the positive x-axis as the polar axis, this is the ray through the point. Say this is the point P. Originally we have x and y, but we can also form using 2 r and theta. Right, and then of course this is the right triangle, so we have this is going to be y, this is going to be x, and we have the same trigonometry as we always have. Sine of theta is y over r, and cosine of theta is x over r. Now with this, multiply r on both sides, or if we just write over 1 and cross multiply, so we have y equal to r sine theta and x equal to r cosine theta. So if we have r and theta, we can go to x and y by this equation. So in that case, we can go from polar coordinates to rectangular coordinates, from r and theta to xy. Right, let's look at this example. Convert the following point to rectangular coordinates. Right, this will be easy, straightforward. This is, so we convert the following points to rectangular coordinate. Rectangular coordinate is xy. So originally we have r and theta. So originally r is equal to 2 and theta is equal to pi over 6. Right. With that, we have convert to rectangular coordinate x equal to r cosine theta and y equal to r sine theta. X equal to r cosine theta 2 cosine of pi over 6, and y is 2 sine of pi over 6. Cosine pi over 6 is square root of 3 over 2, and sine 2 sine of pi over 6, 2 sine pi over 6 is 1/2. And that gives us 2 and 2 cancel out, square root of 3 and 1. So the coordinate, rectangular coordinate, we will write the point xy. X is square root of 3 and y is 1. Simple enough. So here we are given that r is -3 and theta is pi over 4. So to change from r and theta to x and y is straightforward. X equal to r cosine, y equal to r sine. X is r is -3, cosine pi over 4, and y -3 sine of pi over 4. Cosine pi over 4 is square root of 2 over 2. So we have -3 square root of 2 over 2. And sine is also square root of 2 over 2. So we have xy equal to -3 square root of 2 over 2. And -3 square root of 2 over 2. So that is the point in rectangular coordinates. And same thing for the next one. R equal to 5 theta -pi over 3. Right. Once again, from r to theta to xy, we use this set of formula. Right, 5 is r cosine of pi, negative pi over 3. What? Cosine is an even function, so cosine of negative is cosine of positive. And pi, cosine pi over 3 is 1/2. So we have 5/2. And do the same thing. R sine theta for y. R sine of negative pi over 3. Sine is a negative. Sine is an odd function. So sine of negative is the negative sign. And sine pi over 3 is square root of 3 over 2. So we have negative 5 square root of 3 over 2. So we have the point xy 5/2, negative 5 square root of 3 over 2. Right, so simple enough. Of course, we can verify if we want to. I'm just going to do one of them. Let's say 5/2 and negative 5 square root of 3. So let's look at what is negative 5 square root of 3 over 2. Alright, so about negative 4 something. So 5/2, half of 5 on the x-axis, and y is negative 5 square root of 3 over 2. So it's about 4. So we're talking about this point. So 5/2 and negative 5 square root of 3 over 2 is this point. Now, if we look at that again, so the angle is about negative 5 point, negative pi over 3, which is good, and r is equal to 5, so which is good also. Right, so straightforward, right? Now, rectangular two coordinates, rectangular coordinates, two polar coordinates. Rectangular coordinates when we have x and y, and polar coordinate where we have r and theta. When we convert this, of course, we always have r squared plus x squared equal to y squared, and then tangent is y for x. There's nothing new here, right? But I put asterisk here. That is for the note. Remember, when we do the tangent inverse will give us the answer in quadrant 1 and quadrant 4. So what happens if the point is in quadrant 2 and or quadrant 3? Well, that would be a problem. So I put asterisk here. What we just need to do is make sure that it is in the right quadrant. So that is what we have in the note. So theta must be in the right quadrant. The correct quadrant. We'll see those in the example. Convert the following point to polar coordinates. So we convert the point to polar coordinate. We have r and theta. That means originally we have x and y. Right, so we have x and y. So first, to get to r squared equal to x squared plus y squared. If we want to, we can just write r equal to positive x squared plus y squared. If we want to choose r to be positive, we can always do that. So r equal to square root of x squared plus y squared. So we have square root of 3 squared and 3 square root of 3 square. 3 square root of 3 square is 3 square times 3. 3 square is 9 times 3 is 27. So we have square root of 9 plus 27, which is square root of 36, which is equal to 6. So we have r is equal to 6. Now, how do we get theta? Well, to get theta, we use tangent of theta is y over x. Y over x. 3 and 3 cancel out. Give us square root of 3. So if tangent is equal to square root of 3, then theta equal to tangent inverse of square root of 3. And if we use tangent inverse, make sure in the degree mode so we can easily recognize the angle. That's 60 degrees, or we can say pi over 3. Right. Before we answer, just need to check. X is positive, y is positive. X is 3, y 3 square 3, so yes. So this one is in quadrant 1. And we have pi over 3, which is in quadrant 1. So before we write, make sure that it is check. So this one in quadrant 1. So yes, so that's good. So we can write the answer as r and theta. R, the distance is going to be 6. The angle is going to be pi over 3. Right, so that's what we have. We write this point as a rectangular coordinates, as a polar coordinates. Right, next, negative 3 and 3, same thing. X is equal to negative 3 and y is equal to 3. So we will write r equal to square root of x squared plus y squared x squared plus y squared. So negative 3 squared is 9 and 3 squared is 9, so we have square root of 18. Square 18 could be the split the square root of 9, square root of 2, right? Square root of 9 is 3, square root of 2 is still square root of 2. So we have 3 square root of 2. So that is r. Next, to determine the angle theta. Tangent theta is y over x. Y over x. Right, so to get back to the angle, we take the inverse. Tangent inverse of negative 1 is negative 45 degrees, negative pi over 4. Right. Before we answer, make sure that it is in the right quadrant. Right, what we have is x equal to negative 3 and y equal to 3. So the point here is in quadrant 2. But what we have is negative pi over 4. This one is in quadrant 4. Negative pi over 4 is this one. We need to be in quadrant 2. So we have to make an adjustment. We're going to need to add, counterclockwise. We're going to need to add half revolution, so that we end up in quadrant 2. So this is not, it is inverse is correct, however not in the right quadrant, so we have to add a pi to it to make a manual adjustment, so that will be in quadrant 2. So plus pi, so that will be in equal to 3 pi over 4, and 3 pi over 4 is in quadrant 2. Which is good. So when we find the angle, it is negative pi over 4, it is not in the right quadrant. If it is not in the right quadrant, add half a revolution to turn that into the right quadrant. So that is good. Right, so let's write the answer as r and theta, where r is equal to 3 square root of 2, and the angle is 3 pi over 4. Of course, we can also use negative pi over 4, but the radius, I mean r, is going to be negative, but I prefer to keep r positive. Right, so that's what we have. Right, more example. Now we have x equal to 0, y equal to 2. Of course, we can still do the same thing too, right? But usually if it has one of the 0, I prefer not to use that. Just try to draw it, try to x equal to 0, y equal to 2. So that point is in rectangular coordinates. If we want to write this in polar coordinates, notice the angle now is going to be pi over 2, because that's 90 degrees. And the distance is going to be 2. So the point, without doing any math, or just based on the graph, we can say r is equal to 2 and theta is equal to pi over 2. Yeah. We don't have to do r and theta using the formula. Of course, if we can draw it, one of them is 0, it is much better just do that. Same thing for negative 2 and 0. X equal to negative 2, y equal to 0, so we have this point, negative 2 and 0. Now, if this was negative 2 and 0 in rectangular coordinates, x is negative 2, y is equal to 0. Right. Now, if we want in polar coordinate, the angle from the polar ray to that is going to be pi, and the distance from that point to the pole is going to be 2. So we're going to write the polar coordinates is going to be r is equal to 2 and the angle is pi. Yeah, we don't even need to do this. So when one of them, one of the coordinates is equal to 0, it will be easier to just follow that. Alright. Next, transform the following equation from polar to rectangular. Actually, I got this one backward. Sorry. We should transform from rectangular to polar. So it should be from rectangular to polar. Right. From. So originally we have xy for rectangular. we're going to change to r theta. And the formula that we use is going to be this and that. So let me write what we can use. So x equal to r cosine theta, y equal to r sine theta, and then we have r square is equal to x square plus y square, and tangent of theta is y by x. So those are the formulas we have in this section. Right, now we go from xy into r theta, so this will be obvious. The first one comments us directly x squared plus y squared, that is r squared. We don't have to do anything. And then equal to 4, and then x. If we want to write r in theta, it's going to be r cosine theta. So we have that equation. If we want to divide by r on both sides, because we can, both sides have r, so cancel out. We have r equal to 4, r now cancel out cosine theta. Right. So we turn from rectangular equation has x and y in it to a polar equation that has r and theta in it. Pretty much very straightforward. Right, for x, y equal to 16. So for if we have x, that is r cosine theta. If we have y, that's going to be r sine theta. Equal to 16. And multiply it out, we have 4r squared cosine theta sine theta equal to 16. Of course, we can divide by 4 on both sides. So r squared cosine theta sine theta equal to 4. Once we divide by 4 on both sides. Yes, this equation have r and theta, r and theta in it. So this is in polar form, and that's what we do. So it's straightforward, right? Now y equal to x squared. Y is equal to r cosine theta. And x, sorry. R sine theta is y, right? So y is r sine theta, and x is r cosine theta. And we have square on this side. Right, so we have r sine theta for y, and r squared cosine square theta for x. Look like we can divide by r on both sides. So we have sine of theta equal to r cosine square of theta. If we want to, we can just stop at this equation. Or if we want to, we can just divide by cosine square. Either way, we will have equation in terms of just r and theta, meaning in in polar form, right? Equation in polar form only has r and theta in it. Right? Y is r sine theta, r cosine theta square of the x or square r square cosine square, and divide by cosine square. We have this, or we can take sine over secant square if we want to. Right. The next one is a little bit different. Of course, we can just do what we have. Y is r sine theta, right? Equal to square root of 3. X is r cosine theta. Of course, we can divide by r on both sides. So we have sine theta equal to square root of 3 cosine of theta. Now, of course, we can stop there. We have theta there, which is good. Now, if we divide by cosine on both sides, sine over cosine is tangent. And if we want to get rid of the tangent, we take the inverse. And tangent inverse of square root of 3 must be 60 degrees or pi over 3. So we have the equation, just have r and theta in it. In this case, theta equal to pi over 3. So that's what we have. So this equation is equivalent to that. This one is in rectangular form, this one in polar form. Of course, there's another way to do this, more direct. I'm just going to divide by x on both sides. So we have y over x equal to square root of 3. And we have tangent of theta is y over x. So here we have y over x. So that gives us tangent equal to square root of 3. Of course, if tangent equal to square root of 3, the angle is tangent inverse of square root of 3, which is pi over 3. So of course it works out the same way, but this one more direct. So this is just an introduction from the polar coordinates and relation between polar coordinates and rectangular coordinates given by these formulas. So make sure we know that. And the only thing that I need to mention is whenever we use this formula, tangent equal to y over x, make sure that it is in the correct quadrant. If it is not in the correct quadrant, add a pi to it to bring that to a correct quadrant. But that's all I want to cover in this section. See you in another video in pre-calculus. Thank you for watching.